Let's see now how do acids and bases reacts with metal. Okay, all of us know when acids reacts with metal, metal will liberate hydrogen gas. Okay, so now dilute acids like dilute HCl and dilute H2SO4. HCl is hydrochloric acid and H2SO4 is sulfuric acid, reacts with active metals involving liberating hydrogen gas. Okay, like metal plus dilute acid, we will see a different color. Now metal plus dilute acid, metal salt and hydrogen gas is liberated in this. Okay, now we can say sodium. We can you can do some experiment in the lab also if the facility is provided to you. If sodium, small piece of sodium which is put it in a test tube, we take HCl dilute solution only and we put that piece of sodium, what will happen, that piece will start moving very fast. Why? Because it is a exothermic reaction, energy liberates as well as hydrogen gas is also liberated. Okay, and gas bubbles will start coming out and you can observe it, the hydrogen gas is liberating. So sodium metal reacts with dilute hydrochloric acid, you are getting salt as sodium chloride and hydrogen gas is liberated. Similarly, magnesium metal will reacts with dilute sulfuric acid, you are getting magnesium sulfate and hydrogen gas is liberated. Okay, so metals which can displace hydrogen from acids are known as active metals. Okay, so the active metals can liberate hydrogen from acid like sodium, potassium, zinc, iron, calcium, magnesium, etc. These are all active metals. Okay, now activity is there. Just see now first, in order to demonstrate the release of hydrogen in a metal when a metal reacts with dilute acid, we have few activities. Take a few pieces of granulated zinc in a conical flask. Okay, in a conical flask few pieces of granulated zinc will be taken. Here they have taken in a test tube, the zinc granules are taken. Okay, drop dilute sulfuric acid by a dropping funnel. So few little sulfuric acid is added, dilute sulfuric acid is added into it. Okay, third one, pass the gas being evolved through the gas solution. Now what will happen, when zinc granules reacts with sulfuric acid, hydrogen gas will liberate. That liberated gas will pass from delivery tube here and it will start bubbling here. Okay, so in the soap solution we can observe it. So now bring a burning candle near these bubbles, the gas will immediately catch fire and will burn more brightly, accompanied by the sound, pop-up sound will come and the gas will start burning with more intensity, because hydrogen is the gas which is liberating here. Hydrogen is supporter of combustion. Okay, then we can see hydrogen gas burns with a pop sound, making a little explosion. So burning candle is taken close to that, soap bubbles filled with hydrogen, and here it is a trough, in that soap solution is there. Once again I am repeating, there is a test tube taken, in test tube there is zinc granules and dilute sulfuric acid is added into it. When the reaction starts, we are closing with the cork, one headed cork, one whole cork is there, in that side tube is inserted. Here one trough is taken, in that soap solution is there, in that hydrogen bubbles are there. Okay, so hydrogen will start bubbling into soap solution. Why we have taken soap solution? When we observe the bubbles, we can identify hydrogen as liberated. Now when burning candle is taken close to hydrogen, it will give pop-up sound and the small explosion also will happen, which will indicate the gas liberated is hydrogen gas. Okay, now reaction of dilute sulfuric acid, the same experiment is shown here. Now zinc granules reacts with dilute sulfuric acid, the gas liberated is hydrogen gas which is passing from here. Here it is soap solution, in that the gas will start bubbling, hydrogen gas. Burning candle is taken close to the bubbled gas. What will happen? It will make a pop-up sound and it will give a little explosion also. Okay, now bubbles are formed in the soap solution, indicating some gas is evolved during the reaction between the metal and the acid. Now the gas burns with popping sound. Okay, what will happen? Showing that the gas evolved is hydrogen gas. The same observation is found here. Zinc plus dilute H2SO4, you are getting zinc sulfate plus hydrogen gas is liberated. Okay, that only under the experiment we had observed just now. Now the active metals like zinc displaces hydrogen from all the acids, and the remaining part of the acid combined with the metal to form corresponding salt. Like we can say sodium also reacted with acid, hydrogen gas was liberated. Then Fe also, iron also reacts with sulfuric acid, we are getting hydrogen gas liberated, and ferrous sulfate salt is obtained. So like that, the more reactive metals will liberate hydrogen gas from the acid when they reacts with acid. That is only the conclusion here. Okay. Now how metals reacts with base? Let's observe that also, how metals will react with base. Now metals like zinc, tin and aluminium, all of you are familiar with the symbols, zinc, tin and aluminium, okay, reacts with strong alkalis like sodium hydroxide, which is caustic soda also popularly called, and potassium hydroxide, which is called caustic potash, okay, evolve hydrogen gas. Hydrogen gas is liberated. We can see here when zinc reacts with sodium hydroxide. See, yesterday previous classes also we have discussed AQ indicates aqueous. When we are preparing solution in water, we are using aqua, means aqua word is signifying water. So whenever we are preparing solution in water, it is called aqueous. So sodium hydroxide solution is prepared in water, and that solution is treated with zinc. So what will happen? You are getting sodium zincate, Na2ZnO2, and hydrogen gas is liberated. Okay. Now tin also, when tin Sn will react with sodium hydroxide solution in water, we are getting sodium stannite, Na2SnO2, and hydrogen gas is liberated here also. So what is our conclusion? The strong alkalis or metals, okay, will be, whenever they react with any kind of metal, the active metal, you are getting hydrogen gas is liberated. Aluminium reaction also we can see, reaction must be always balanced. The number balancing also has to be done. If reaction is not balanced, we have studied in previous classes how to balance a reaction. So if the reaction is not balanced, you might lose the marks in the exam. So balancing reaction is very, very important. Why? Because according to law of conservation of mass, the number of moles which is reacted should be equals to number of moles which is produced. Okay, that is why balancing is must. Now Al, 2Al plus 2NaOH plus 2H2O, you are getting sodium meta aluminate 2NaAlO2, and hydrogen gas is liberated here also. Okay, so we have seen reaction of strong alkali sodium hydroxide with three metals, zinc, tin and aluminium. We have reached to the conclusion. We have got zincate, stannite and aluminate. Along with that, hydrogen gas is liberated. What is common? The hydrogen gas is liberated in all. Okay. Now in a test tube, take a few granules of zinc. To this add small amount of sodium hydroxide solution prepared in water. Warm the tube and hydrogen gas will liberate. It will catch fire when a burning candle is brought in its contact. Same way we will do the experiment. There we have done zinc granule, we have treated with HCl, and burning candle, when it is taken close to that, it was burning with the pop-up sound and small explosion. Here now zinc granules we are burning with alkali sodium hydroxide, and the liberated gas again we are trying to touch with burning candle, same type, it will catch fire and enough pop-up sound will come. So what it indicates? Hydrogen gas is liberated. It is observed that metal like zinc reacts with strong base like sodium hydroxide and potassium hydroxide to liberate hydrogen gas and form corresponding salt. So sodium zincate is the salt and hydrogen gas is liberated. Okay. Now some metal reacts with bases to liberate hydrogen gas like aluminium. When reacts with sodium hydroxide solution in water, we are getting sodium meta aluminate and hydrogen gas is liberated. Tin also solution of sodium hydroxide, it is treated, so we are getting sodium stannite and hydrogen gas is liberated.